Hey guys, so today we're going to talk about arithmetic and geometric sequences. So an arithmetic sequence is a pattern in which you either add or subtract by a fixed number to get to the next number. So the pattern 3, 8, 13, and 18, that's an arithmetic sequence because to get from 3 to 8, we add 5. To get from 8 to 13, you add 5 more. To get from 13 to 18, you add 5 more. So to get from one number to the next, you added a constant term, which in this case is 5. So there's an explicit formula that you can use to generate the rule to get you any number that you're looking for, any term that you're looking for. Because if you're trying to get like the 100th term, you don't want to write this pattern out 100 times until you get to the 100th term. So the general formula is a of n equals a of 1 plus n minus 1 times your common difference. So a's subscript n, a of n, that is the nth term. So whatever term you're looking for, that number goes there. A sub 1, that is your first term. N is, again, the term that you're looking for. If you're looking for the 100th term, you put 100 here where n is the term number. And then D is your common difference. So how much is it increasing or decreasing by? So let's take this pattern and see if we can generate a formula for it. And then we're going to go back and find the 10th term. So let's try to derive this formula from the pattern that we have. In case you don't memorize the formula, you can always go back, think through how you get to the formula, how do you get from one number to the next number. So the first term we know is 3. So a of 1 equals 3. A of 2. So you're looking for the second term. The second term is 8. The way we got to 8 is we added 5 to the first term. So 3 plus 5. The third term is 13. So we got that by taking 8 and adding 5 more. But we're going to keep it in terms of the first term. So it's 3 plus 10. Instead of putting plus 10, we have added 5 twice. So we're going to put plus 2 times 5. And then to get to the fourth term, we took our first term and added 15 to that. Right, so 13 plus 5 is 18. We added another set of 5. So that's 5 plus 5 plus 5. So we did that 3 times. 5. So if you notice, whatever term you're looking for, so if you're looking for the third term, you would do 2 times the common difference. If you're looking for the fourth term, you would do 3 times the common difference. It's 1 less than the term that you're looking for. So that's why in the formula it's n minus 1. So a of n equals a of 1 plus n minus 1 times d. So we're going to go through, fill in each one of these for the 10th term, and we're going to try to figure out what it is. So a of n, so a of 10 equals a of sub 1, that's your first term, and that's going to be 3, plus the term you're looking for is 10. So 10 minus 1 times your common difference. Common difference here is 5. And 10 minus 1 is 9. 9 times 5 is 45. 45 plus 3 is 48. So the 10th term is 48. Alright, so next one. Let's say we have the pattern 5, 8, 11, 14. What is the, write the equation and find the 100th term. So the general equation, the explicit formula, is going to be a of n equals your first term, that's 5, plus n minus 1, and the common difference to get from 5 to 8, we added 3. From 8 to 11, we added 3 more. 11 to 14, we added 3 more. So they all are increasing by the same number. So we're going to put 3 here for a D. So now we're going to go back, use this formula that we just wrote, and try to find the 100th term. So we're going to substitute n for 100. So a of 100 equals 5 plus 100 minus 1 times 3. So 99 times 3 is 297 plus 5 is 302. So the 100th term is 302. Alright, so one more. So 2, 6, 10, 15. Write the equation and find the 100th term. So let's see if we can figure out how these are increasing, how much these are increasing by. So from 2 to 6, we added 4. From 6 to 10, we added 4. From 10 to 15, we added 5. So it's not increasing by a constant term, so therefore it's not an arithmetic sequence. Alright, so all these numbers need to be increasing by the same amount or decreasing by the same amount for it to be arithmetic. Since this last one is by 5, the other ones are by 4, it's not arithmetic. Alright, next set. So the next part of this is geometric sequences. So it's a pattern in which you multiply by a fixed number to get to the next number. So let's say you have the pattern 5, 15, 45, 135. To get from 5 to 15, we multiply by 3. 15 to 45, multiply by 3. 45 to 135, again, we multiplied by 3. So it's all being multiplied by a fixed number to get to the next number, so that tells you it's a geometric sequence. The explicit formula. So this formula is going to be a little different from arithmetic. It's going to be a of n equals a of 1 times r to the power of n minus 1. N has to be greater than 1 for you to use this formula. So n again stands for the nth term. A is sub 1. That's your first term. R is your common rate. Your rate, how it's going from one number to the next. What do you multiply by to get from one number to the next? So in the case up here, we multiplied by 3. So R would be 3. And then again, n is your term number, whatever term you're looking for. So if we're going to write the equation for this one, your first term, a of 1, is 5. So up here we have our first term being 5. And then we're multiplying it by 3. So the first term is, the first term is 5. You multiply by 5, and then your common rate is 3. And then it's n minus 1. So that's the general formula for this pattern. So let's find the 7th term. So now we're going to plug in 7 where n is. So 7 minus 1 is 6. 3 to the 6th power times 5. That is 3, 6, 4, 5. Alright, so again, all we did was we took the first term, plugged it into a of sub 1. We found the rate, how much it's increasing by each time. So what do you have to multiply by to get from one number to the next? We found that to be 3. So R is going to be 3. You're looking for the 7th term, so you plug in 7 where n is. 7 minus 1, that gives you 6. Then follow PEMDAS. Make sure you do exponents first before you multiply. Alright, so let's do a couple more. So we have negative 16, 8, negative 4, 2. We're going to try to find the 8th term. So the first step is to figure out how these numbers are changing. So to get from negative 16 to 8, what we did was we multiplied by negative 1/2. So you have to have the negative sign there. That tells you you're alternating signs. And then to get from 16 to 8, you divide by 2, which is the same thing as multiplying by 1/2. And from 8 to negative 4, you multiply by negative 1/2. From negative 4 to 2, same thing, multiply by negative 1/2. So we're looking for the 8th term. So a of sub 8 equals your first term, negative 16, times your rate. Your rate is negative 1/2. So to get from one number to the next, we multiplied it by -1/2 all the way through. And then your exponent is going to be 8 minus 1. You're looking for the 8th term, so n is going to be 8. Always subtract 1. So let's go through and do that. 8 minus 1 is 7. -16. So times, make sure you do exponents before you multiply. So -1/2 to the 7th power is going to be a -128. -1 over 128. And then you multiply that together and you reduce it to get 1/8. One more. So let's say we have a sub 1 is 2. Your common rate, your rate between them is 4. Let's find the 7th term. So with this one, they don't give you a pattern, but they give you what each letter represents. So they give you the first term. We're looking for the 7th term, so a sub 7 equals your first term, which is 2, times your common rate. Since they give you r, that tells you it's a geometric sequence. If they were to give you d, that's your arithmetic sequence. Times r is 4 to the power of n minus 1, so n we know to be 7. We're looking for the 7th term, minus 1. So 2 times 4 to the power of 6. Multiply that together, and you get the 7th term being 8,192. Alright, hope that helps.